Now, in this lesson of solving equations with variables on each side, every equation in this lesson has variables on both sides of the equation. You can solve such an equation by getting the variable terms on one side of the equation and the constant terms on the other side of the equation. So we're going to do an example of this. Solving an equation with variables on both sides. First thing, you will subtract 7n from each side. Now, if you would like, you could have subtracted 10n from each side. It makes no difference. Your goal is still the same, for your variables to all be on one side and your constant terms to be on the other side. Now, since I have subtracted 7n from each side, I'm now going to subtract 13 from each side, my constant term. Which now I have my constant term on one side, my variable on the other. Negative 6 is equal to n. Okay, so on this next practice, I'm going to subtract 3n from each side. Oops, excuse me. Now I'm going to add 2 to each side. Divide each side by 2. N is equal to 4. Okay, on 2, I'm going to subtract 8y from each side. Now add 17 to each side. Seven is equal to y. So it does not matter which direction you go with your variables, your coefficients, just so long as what you do to one side, you do to the other, so that your constants are on one side and your variables are on another. So let's do another one, number 3. Focus on getting the variable on one side, the constant term on the other. This one I'm going to subtract m from each side. Then I'm going to subtract 15 from each side. Finally, divide each side by 8. Negative 2 is equal to m. Now we're going to use this concept by solving equations. Now this is a problem-solving equation. So the Spanish Club is arranging a trip to a Mexican restaurant nearby. Those who go must share the $60 cost of using a school bus for the trip. The restaurant's buffet costs $5 per person. How many students must sign up for this trip in order to limit the cost to $10 per person? And they've asked for you to let S represent the number of students. Now, this word problem, think about the type of equations we have been using in the previous slides. We have been having a variable plus a constant term equaling another variable with variables on each side. What will our constant term be in this equation? Yes? $5. No, not $5. What is the constant term that's not going to change that everyone has to share the expense in? Yes? $60. So with that, knowing that a constant term is going to be $60, we're wanting to know how many students can go, not paying over $10 a student, And each student, how much is the buffet for each student? $5. So I'm going to pause this, and we're going to think about which order to put this in order to determine where each student does not have to pay over $10. So notice we have on the left-hand side of the equation $60 because that's our constant term. Everybody must share in that expense. Then everybody is going to have to pay for their own buffet. So $5 per student plus the $60 is equal to 10 times a student because we don't want them to have to pay more than $10. So how many students will have to go on this trip in order for them not to have to pay more than $10? I'm going to solve this. How many students can go? So 12 students will be your final answer. Again, you use the information that was in there, the constant term that everybody had to share the expense, plus their buffet that they had to pay for, and they did not want to go over $10 per person. Now you're going to notice in some of your problems now, you have two more options. You'll notice that your solution either has no solution or that every number is a solution or all numbers. So in our next examples, we're going to demonstrate those. In example 3, an example with no solution. Let's simplify the left-hand side of the equation. 10x plus 5 equals 10x because we use the distributive property. Now if I subtract 10x from each side, I have 5 is equal to 0. 5 is not equal to 0. So this answer, when you have a problem like this, you will put no solution after you show your work for this. The statement 5 is equal to 0 is not true, so the equation has no solution. So in our next example, solving an equation with all numbers as a solution. Let's simplify. If you'll notice, these are the exact same. So no matter what you put in for x, it will always equal. So your solution for this one, the answer that you would put in there, is all numbers. You will show your work, then your final answer will be all numbers. In example 5, we're going to solve an equation to find the perimeter. Find the perimeter of the square. What do you know about a square and the sides? They are all the same. So in order to determine what x is, each of these sides are equal. So since the clue would be it is a square and all the sides are the same, you would set up 2x is equal to x plus 4. I would subtract an x on each side. X is equal to 4. They're asking you to find the perimeter, so we are not done yet. We just found out what x is. So we are right now going to substitute 4 wherever you see x. Each of these sides is 8. 8 times 4 is 32, so the perimeter is going to be 32 units. Now we are being asked to write the verbal sentence as an equation, then solve the equation. I'm going to pause this video, let you read the verbal sentence, set it up as an equation, and then solve for it. So we've set up our problem. 8 times a number equals 24 more than 2 times a number. So now we're going to Subtract 2x from each side. X is equal to 4. So we set up our problem. 6 plus 2500 x is equal to 0.8 x minus 5. We decided that we would subtract 0.25 from each side, which left us with 6 is equal to 0.55x minus 5. Add 5 to each side. 11 is equal to 0.55x. So now I'm dividing each side by 0.55. When your divisor is a decimal, you have got to make it be a whole number, as you've been taught before. So you move your decimal over twice here, you move it over twice here. 55 goes into 110 twice, but yet I have another 0 I need to bring down, so the answer is going to be 20. Now we're going to continue with using problems that we've done before, but now we'll have a little twist to it. 4 times the sum of 3 consecutive integers is 180. What are the integers? We have worked with the sum of consecutive integers, and now we're adding 4 times. So I'm going to pause it, come back, and show you the answer. So we set them up. On the left-hand side, you need to make sure you have x as your first, x plus 1, then x plus 2, because they are consecutive numbers. That was our first clue. Then our next one was 4 times the sum. So we put those in parentheses so that we could multiply 4 times it. Before we did that, we combined the terms on the inside. So now I have to use the distributive property. 4 times 3x is 12x plus 12 is equal to 180. I'm going to subtract 12 from each side. 180 minus 12 is what, class? 168. Divide each side by 12. You need to learn how to work that out on your own, but for right now, guys, what is 168 divided by 12? 14. 14. Am I done? No, your first number is going to be 14, then 15, then 16. Very important that you remember how to do this.
Do you get the answer?
On the next one, we're going to find, this is our last slide, we're going to find the perimeter of the square. What do we know about the sides of a square? They are all the same. So we're going to use the same concept as we did on example 5. And we're asked to find the perimeter. These are 2 examples here. Here's our first one. We have 2 problems, and here's the second one. 2 separate problems. So we have 3x minus 5x is equal to 4x. We are now going to solve wait a minute, sorry. I am not done because it's asking you to find the perimeter. So now I'm going to substitute 4 for x. Perimeter, each side is 16. 64, perimeter is 64. Does not give us what the sides are, so it's going to be 64 units. Now I'm going to pause this and let you do the next one on your own. Since again, this second problem is square, all sides are the same. So our sides are x plus 3, but there's 4 of them. And we know that it's 32 units. So we are going to simplify. They're asking for the value of x. X is going to equal 5. That's all you have to do on those. Our lesson is solving problems with variables on each side. We use that field with perimeter. We use it finding a solution for certain word problems.